Hey, how are you doing this morning?
Good. I was going to ask you.
Oh,
Sounds like you had a pretty eventful night.
yeah, but everything's okay and
Good.
just took longer than I was expecting. So,
I'm glad everything is okay.
yeah. And then I think I'm ready whenever you are.
Just pulling up my quiz. The due dates in this class are so weird.
Yeah.
Like it says it's overdue, but we have until 11 o'clock tonight.
Yeah.
All right. I'm getting my quiz started now. Okay, two. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? And that is a simple random sample is drawn from each of the populations and X bar is normally distributed.
And wouldn't we also say that this sample size, well, maybe not the sample size being the same for each group.
I don't know. I mean, that might be a requirement also. It just says there are two requirements that need to be checked when conducting a hypothesis test for two means with independent samples. And then it lists those two, but let's see. Remember, the second requirement will be satisfied if the original populations are normally distributed or if the sample sizes are large.
Okay, yeah, then I will mark that one. It just, like, in my mind, it makes sense that the sample sizes would need to be the same size.
Right.
But
Me too.
But statistics doesn't always make sense. So the test statistics for a hypothesis test comparing two means with independent samples is a t-score, right?
I think so.
Yeah.
Yeah. So I was really, really confused on when to know if you should use the upper or the bottom line in the data. Does that make sense?
Yeah.
And I feel like they didn't give really good information on when to use either.
Yeah, watching the videos, it seemed like he always used the bottom, but...
And that's what it made it sound like when, like, well, like they said one thing, and then in each of the examples, they were always using the bottom score.
Yeah.
So maybe it's just the bottom.
Yeah, I think...
All right, oh, pardon?
Yeah, I was going to say, I think, like, from the videos, he may have actually said that we always use the bottom.
Okay, cool.
I don't know.
Okay, two samples are independent if knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Yes. So, for the next question, use the dentist office bills for dentist offices in Idaho Falls and Rexburg. And mean 1 is the office in Idaho Falls. Mean 2 is Rexburg. So perform a hypothesis test to determine if the mean bills at Idaho Falls office is less than the mean bills at the Rexburg office. Which means we'll have a null hypothesis of mean 1 equals mean 2, and alternative hypothesis of mean 1 is less than mean 2. The level of significance is 0.1. So what are the degrees of freedom? And in here, it says, hold on, because we've got to do the recoding thing. So I'm coming up with 37.996.
Okay, I'm still doing the recode.
Okay. Yeah, I went over that several times because like it was confusing to me.
So we put the, yeah, I get confused too. Which variable do we put in the box?
Okay.
It would be the city, right?
Yes. So you
Not the dentist bill?
hang on. So yeah, the city is what you're recoding because that'll give you, we have Idaho Falls and Rexburg and we want to turn it into 1s and 2s.
Okay, great. And now to get the other stuff, you do the t-test, right?
You do it's actually, hang on.
The independent samples t-test?
Yes, the independent samples t-test. Yeah.
Okay.
Because that gives you the 2 different lines.
Okay, and what did you get for the degree of difference?
Well, if we're using the bottom, it's 37.996.
Okay, that's what I have too.
Which it would be interesting to know why, because generally, and maybe it's because we have 2 different sample sizes or sample tests, or not sample tests, but groups, that it's slightly different from your normal.
I don't know.
So
Okay, and then for the sample standard deviation for Rexburg, 1 second. It would be 206.637.
yeah. And then the test statistic would be negative 0.434.
Uh-huh. All right, the p-value. So is this 0.666 divided by 2?
I think so. But do we need to click on it to get our bigger number?
I don't know. When I double click on it, I don't get anything.
Okay, yeah.
Oh, there it is. Yeah, I do.
Okay. What bigger number are you getting? Because I can't get it to.
0.666475.
So then I get
0.333.
Yeah, that's what I'm getting. So our p-value is larger. So I always get messed up on this. We fail to reject the null hypothesis?
Yeah, we fail to reject it.
Okay.
I can remember that, but I can't interpret it very well. They're like, well, then what does that mean? And I'm like, no idea.
So I think
Let's see.
because we didn't reject the null hypothesis, so the null hypothesis is true.
Mm-hmm.
So we have insufficient evidence that they're different,
Right.
hopefully.
That's what I think.
Okay.
Okay.
Okay, so
Sorry, just bringing up the new data.
yeah.
Okay, for the next 6 questions, use the data file freshman dinner. This data represents the number of times freshmen students from Utah and Colorado cook their own dinner in a month. Let mu1 represent the mean number of times a month that a student from Colorado cooks dinner, and let mu2 represent the mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is U1 equals U2, and I think the level or the alternative hypothesis would just be does not equal.
Yeah, because they're just wanting to know if it's different, not if it's greater or less than. So
Uh-oh. Wrong. Oh, I was trying to do automatic recode and I did it very wrong.
well, this answers are if the sample sizes need to be the same because we have 10 from Colorado and 12 from Utah.
Mm-hmm.
So
Okay. So,
let me know when you have it pulled up.
okay, so the t-square is negative 0.845.
Yep, and our p-value would be 0.410 because it's two-tailed.
Great. Okay, let's see. We reject the null hypothesis, right? Wait. We fail to reject the null hypothesis.
Yeah. And then determine the margin of error for this 95% confidence interval. And how did we do this last time?
We just subtracted the upper value
Okay.
by the mean.
Okay.
Isn't that right? And did we get it right? I can't
I
remember.
think we finally got it right, but the problem is we did it so many different ways trying to get it right.
Exactly. But it's hard to remember.
Okay. Where's the mean? Oh. Okay, so I'm getting 0.59585, so 0.596.
What did you use as your upper?
Oh, I used the low or the upper one, so I need to do that again. Sorry. Let's try. Oh, yeah. Let me try this again. I also didn't make it a negative for the.
So when you do these, though, for the independent variables, are you using values off of the independent samples test box or from something else?
I think so, because this gives us the difference between both of them.
Okay.
Okay, so when I did it correctly, I got 3.671.
And which numbers are you using?
So the 2.20401 for the upper, and then the negative 1.46667. Oh, except I didn't.
So you use the mean difference?
Yes.
Okay.
Only I forgot to add a 6, so apparently I can't type today.
204. So you got 3.671?
Yeah.
Okay.
Oops.
Okay, and the lower bound would be negative 5.137.
Yeah. And then the upper bound would be 2.204. Wow, that went like really fast.
Oh, we're done?
Yeah, that was the last question.
Okay, that was way faster than the last one.
Yeah. So
hopefully we got them right.
Yeah, let's submit and see what we've got.
We got it right. We got them right.
Cool.
Oh, thank you for teaching me the confidence interval thing. I was confused because I thought you were supposed to use I just didn't know what to use for that. for the independent samples.
Oh, dude. So you can view feedback when you look at the quiz. And it'll
No way.
Yeah, under each question. That would have made like so much easier. Because yeah, determine the margin of error for the 90 in the answer in SPS is slightly lower than in Excel. So the answers given is the average between the two results. Your results should be close to the answer shown. Okay, so maybe not a whole lot. Okay, never mind. It doesn't. It just says that they're different.
Cool. And I think so I also realized recently, once the time ends for the quiz, like once I didn't know this until recently, once the due date has passed, the correct answers get put next to all of your quiz questions if you get them wrong. So you can look back and actually try to figure out what the right answer is.
Cool.
Yeah. I couldn't take one of the quizzes. I couldn't take one of the quizzes over the weekend, the homework quizzes, because our power went out.
Yeah.
And so I emailed the professor and I was like, I really want to take this quiz. Please let me, And he let me, but then when I went in to take it again, it had all the correct answers. So then I like emailed him and I was like, I feel like this is cheating.
Yeah.
Anyways.
Well, I've never had a class where you have like multiple times that you can take the quizzes. Generally, it's just one and you're done. And so it's interesting, but nice.
Yeah. Yeah.
So.
All right. Well, have a good weekend.
Yeah, you too.
And I'll see you on, does Monday work?
Yep, Monday should work.
Okay, great. And then I think next week we have an exam.
Yeah.
So, okay, cool.
Okay, see you then.
Well, I'll see you later.
Okay, bye.